beginning with what crop tree release is, what we know about it, and the study objectives, and then moving on to study design and methods, and then I'll get into the results and wrap up with just some closing remarks that tie the study back to some of these challenges. So I'm going to be pretty brief here and ignore some of the complexities, unfortunately, that face challenges, the challenges that we face. But to put it kind of briefly, the oak-dominated forests across the eastern US are aging and under a kind of a new disturbance regime that's marked by fire suppression and higher canopy densities. Shade-tolerant species have proliferated in the mid-story. The disturbance regimes that led to the rise of oak were marked more by wildfires that controlled understory conditions and particularly controlled the less fire-resistant competitors of oak, and also controlled some of the density of the canopy so that the understory conditions were favorable for oak regeneration, and the light levels at the forest floor were more medium. And currently there's lower levels of light at the forest floor and less fire. And under this novel disturbance regime, like I said, shade-tolerant species dominate the mid-story, and now canopy gaps are promoting succession to these shade-tolerant species, and larger canopy gaps, such as clear-cutting, promotes shade-intolerant species, such as yellow poplar. In addition to those biological challenges, we also are facing some kind of unique social challenges, one being forest parcelization. This refers to a large forest tract being divided into smaller forest land holdings, and large forest tracts that were owned by one person now being owned by multiple people. And it becomes, on these smaller forest land holdings, it becomes even more important for landowners to be able to minimize their costs while maximizing their production. And also, in addition to smaller forest land holdings, these are often family forest owners who have more complex management goals, not necessarily timber management. The top 5 reasons for family forest owners to own forest land are beauty or scenery, leaving to heirs, protection of nature, privacy, or it's just a part of their home, or maybe a vacation home or cabin. So given this backdrop, we need silvicultural tools that promote oak growth and persistence. I would highlight that oak relies on disturbances, and that active management provides us the opportunity to create disturbances that will promote oak growth and persistence. But these tools need to be applicable on small forest land holdings, which means they need to be scalable and also accessible to landowners who maybe don't have experience with forest management, and also within those complex management plans. So this could mean that it needs to be an aesthetically pleasing silvicultural treatment, or that it needs to promote partial harvesting, which has increasingly become the favored way of harvesting with landowners. So I believe that crop tree release would be one of those silvicultural tools. What crop tree release is a silvicultural treatment where you identify crop trees in a stand and release them by removing the competing trees right around them. So it would look something like this. As you can see on all four sides of that crop tree, cut down the trees or treated them in order to give the crop tree space and access to light for growth. So that's a fairly vague definition. And part of the reason is because crop tree release is a pretty flexible treatment. And given its flexibility, pretty early on in research of crop tree release, Trimble asked several questions that would help narrow down the possibilities of crop tree release. So one question he asked is, at what age should you apply crop tree release? And what I want to do here is go through several suggestions that have emerged throughout the research on crop tree release. So as far as what age, generally the suggestion is after canopy closure, or other people suggest 25 feet tall, and then all the way up to 90 years old. So that's a really wide range of stand age at which crop tree release is effective. As far as how many crop tree release, or crop trees to release, excuse me, it's a difficult thing to determine because of the wide range in age. After canopy closure, there's a lot of potential crop trees, and there's a lot fewer potential crop trees if you're applying it in a 90-year-old stand. So some of that depends on the age at which you apply crop tree release. What type of crop tree should be selected and released? There's a more general agreement on the type of tree that you're looking for. In particular, for timber, that would be a dominant or a co-dominant crown class, potential grade 1 or 2 butt log, a tree that's well formed and vigorous. So essentially, the best tree that you can find out there makes the best crop tree. And as far as how intense, in general, the suggestion is all size, although this is somewhat species dependent. Some species respond well to a 3-sided release rather than a 4-sided release. And a 4-sided release does come with kind of a caveat or a warning that increased light levels can cause epicormic branching in some species, and that the epicormic branching can cause a reduction in butt log value. And then the final question is, what is the cost? And it's another thing that's rather undetermined. There's been very few economic studies on crop tree release. So the objectives of this study were to evaluate the effects of crop tree release on the growth and quality of white oak crop trees, but then to also expand beyond just a tree-focused perspective to a stand-wide perspective and look at the effects of crop tree release on the structure of these upland white oak stands. I will mention that we also have an economic aspect to this study, and I'm not going to present the results from that in this presentation because there are several caveats and it would honestly take me too much time. And I'm trying to keep this fairly brief, especially since we're over video, and I know that sitting in front of a video for a long time can be kind of grueling. So let's move into the study design. This was installed in 1983 in Robinson Forest, UK's research forest in southeastern Kentucky. The stands were upland oak, 70 to 80 years old in age. And generally they contained large pole to small saw timber sized trees, an average basal area of 111 square feet per acre, and 58% of this basal area was white oak. So these were white oak dominated stands. And the side quality, the side index was an average of 73 for white oak, and that's a base age of 50. So the treatments were selected based on 3 assumptions. The first assumption is that a crop tree can grow up to 0.3 inches in diameter annually. The second assumption was that the average crop tree size at the time of installing the study would be 13 inches in diameter, and given the growth rate, the final crop tree size after 35 years would be 24 to 26 inches in diameter. So with those assumptions, we found that 34 crop trees that average 24 inches in diameter would occupy 80% of the growing space of an acre. So 34 crop trees per acre was one treatment level. The second treatment level, 20 crop trees per acre, was selected based on the assumption that any more than 34 wouldn't allow for continued growth of the crop trees throughout the rotation. And 20 was somewhat arbitrarily selected as a number. However, based on that really important assumption that it should be fewer than 34. So each treatment was replicated 4 times in 4 stands that were 2 acres in size. And then the final treatment, the control treatment, crop trees were identified, but they were not released. In order for a crop tree to qualify for selection in this study, it needed to meet 5 criteria. First, it needed to be dominant or co-dominant in crown class. Second, it needed to be white oak. Third, a potential grade 1 or 2 butt log. And 4, even spacing throughout the stand. And then last, if all of those things are equal, the tree that's larger. The release was a crown touching 4-sided release, which means that any tree that touched the canopy of the crop tree was felled with a chainsaw. And this included trees that would grow into the canopy after release. So very small trees weren't removed, but trees that may not necessarily be touching the canopy quite yet were. And this also excluded neighboring crop trees. So that some crop trees received only 3-sided release if they were neighboring a crop tree. A half-acre measurement plot was installed in the middle of every 2-acre plot. And within this permanent plot, every tree greater than or equal to 1 inch in diameter was tagged with an ID tag and measured, and that included the crop trees. And the measurements that were taken were species, diameter at breast height, crown class, and for crop trees, the U.S. Forest Service grade. We measured it 5 different times. I was able to participate in the final measurement in the spring of 2019. So the study was installed, like I said, in 1983, remeasured 5 years later in 1989, and then 10 years later, or 5 years after 1989 in 1994, in the spring of 2001, and then in the spring of 2019. So one thing to point out here is that the intervals between measurements aren't consistent, and that did affect the analyses we were able to do. So the variables that we developed from the measurements taken there were 2 variables for the crop trees. The first is periodic annual increment of DBH, which I'll talk about here in a second. And the second was the maximum potential grade, and that's our quality variable. And again, I'll explain what that means here in a second. And this, as far as stand level variables, we looked at basal area per acre, percent stocking, and ingrowth. So periodic annual increment of diameter is an annualized rate of growth over a period of time. So to kind of explain this, I want to walk through an example. One crop tree had a diameter in year 0 in 1983 of 13.85 inches, and then in year 5 in 1989, it grew to 14.82 inches. So that's a period of 5 years. And the way to calculate the periodic annual increment is to take the difference between those two diameter measurements and then divide it by the period. So the rate of growth for this crop tree over those 5 years was 0.19 inches per year. So this was calculated at the crop tree level. It was calculated for each crop tree in each period. And then the average was taken by plot. The maximum potential grade, or the MaxPG, refers to a binomial variable that we developed based on whether or not a crop tree either reached or failed to reach its maximum potential grade. So to explain what we call a maximum potential grade, I want to briefly just mention what USFS tree grade is based on. The first step in grading a tree is to look at its diameter, and there are diameter classes that affect what grade a tree can qualify for. So if a tree is between 9.6 inch, 6 and 12.6 inches, it can be a grade 3 tree. Between 12.6 and 15.6 could be a grade 2, and greater than 15.6 could be a grade 1. So again, quick example, a crop tree that has size 16.4 inches in diameter had a maximum potential grade of grade 1. Now, just because it can qualify to be a grade 1 tree doesn't mean that various defects or issues with growth or maybe rot might bump it down to be a different grade. So the maximum potential grade represents the grade that it could be based only on diameter. So we developed a binomial variable where 1 meant the crop tree was the best grade it could be, and 0 meant it failed to reach the best grade it could be. And then develop plot level summaries again with the number of successes and the number of failures in the plot. The stand level variables were a little bit more straightforward, pretty typical forestry variables. We calculated the basal area per acre. It's calculated by multiplying the constant 0.005454 times the diameter squared. And then because it was a half-acre measurement plot, multiplying it by 2, which would be the expansion factor. And this was summed for plots and expressed in square feet per acre. And we calculated percent stocking following Gingrich, 1967, pretty typical for the upland oak stands. And then ingrowth was calculated in trees per acre. And what ingrowth refers to is any tree that grew into that diameter class of greater than or equal to 1 inch after the study was installed, after the 1983 measurement, and persisting through 2019. So that meant that anything that grew into that diameter class and was still alive in 2019 was considered ingrowth. And we averaged those by treatment. As far as the statistics that we performed, in general, these were repeated measures, analysis of variance and ANOVA. We used a type 3 ANOVA, and tested the main effects of treatment in year or period for the case of periodic annual increment, and the interaction effect of treatment in year or, again, period. The post hoc tests that we performed were pairwise comparisons using Tukey's honestly significant differences, and we evaluated the results at a 0.05 significance level. Those are the packages at the bottom that we used in R for anybody who's interested. The one difference, we performed that repeated measures ANOVA for all of the variables, except for the binomial variable. We developed a binomial model instead, where the response variable were those successes and failures. And again, it's the main effects for treatment in year, and the interaction effect was treatment times year. And it was also like a repeated measures ANOVA, but the p-values were calculated using a chi-square test instead of an f-test because it's a binomial variable. Okay, moving into the results of the study. As far as the diameter growth, we found that release trees had a higher periodic annual increment on average than unreleased trees. We found that it didn't matter whether or not you released 20 or 34 crop trees. Just to kind of walk you through this table, the subscripts by the mean values there indicate differences, statistical differences. If they have different subscripts, then they're statistically different. So the 20 CTR treatment and the 34 CTR treatment are not statistically different from each other, but they are both different than the control. Now, I will note that those differences look fairly small. However, if you look at a graph of the diameters over time, here you have the 34 treatment in red and the 20 in blue. You can kind of begin to see how those small increases in growth add up over time. And I think an even better way to look at this graph is to just put them all at the same starting point. And if you look at those numbers on the side at the top, that's just the total change in diameter over time. So we can kind of see here how those small increases in rate of growth can add up to pretty significant increases in diameter over the 35 years. As far as the quality of crop trees, we found that similar to the rate of growth, that release increased the likelihood that a crop tree would reach its maximum potential grade. So again, it didn't matter whether or not you released 34 or 20 crop trees, both were more likely to reach their maximum potential grade than the control on the unreleased crop trees. And these results really, they make sense from a perspective of crop tree release because it's a tree-focused treatment. You would expect that the effects of it would be on the individual tree, and it wouldn't necessarily matter between 20 and 34. The difference between the treatments are going to cause differences in effects. So expanding beyond the crop tree level to stand level, we found that crop tree release also stimulates stand-wide growth. So this is the basal area per acre, and as you can see, the basal area per acre converges over time. Again, the letters here represent statistical differences. So we found a difference between the basal area per acre at every measurement year except for the last year. And basically what this represents is the stand-wide growth that's stimulated by crop tree release. And another way of looking at it is this percent stocking chart. The control treatment is on average overstocked. See, it's above that 100% level throughout the rotation here. And the treated, the released treatments are just below overstocked, and they, over time, they converge with the control treatment and reach that upper limit of stocking. I would note here that it's a little bit hard to tell, partly because of the gap in measurement years between 2001 and 2019. However, it does seem to be the case that the released treatments are still growing, that they haven't quite reached the upper limits of stocking. So that's a good sign as far as stimulating stand-wide growth. And last in the stand level, the ingrowth was very, very similar across treatments. It all hovered around 600 trees per acre. And the species compositions of the ingrowth were fairly similar too. I would especially note the species in blue. That's your maple and your beech, those shade tolerant species that have proliferated in the understory and midstory of these oak dominated forests. And also the light green right next to the blue is eastern hemlock, which is another shade tolerant. And if you just look at those three slices all together, you see that the majority of the ingrowth, regardless of treatment, are these shade tolerant trees. I would note too that the white oak is in that darker green, and those are all similar percentages across treatments, 11, 13, and 12. Okay, moving into just some closing remarks, trying to tie some of these results back to those challenges and back to the questions that Trimble asked about crop tree release. I want to start with just revisiting Trimble's questions and how this study fits into just the greater body of work about crop tree release. First, as far as what age, we found that crop tree release was effective in stands age 70 to 80 years old. So it confirms that upper threshold of 90 years old as a possibility. As far as how many, we found in stands of this age anyways, that either 20 or 34 per acre could be released with good results. I would give the caveat here that by releasing 34 per acre, there were some compromises that had to be made in what kind of crop trees we selected. So we had to select smaller crop trees, and so that 34 per acre maybe should be taken with a grain of salt, or considered that you might have to make compromises in the size of the crop tree that you select. Now, as far as what type, it's effective for white oak. I would say here that there's been a lot of research done on red oak and other oaks, but less on white oak. Apart from this long-term study, there's only been a couple other studies on it. And then as far as how intense the four-sided release was effective here, but I think of more specific to this study, we found that rather than epicormic branching being a problem that reduced butt log value, that it was actually the opposite, and crop tree release seemed to increase the likelihood of a crop tree releasing its maximum potential grade. So as far as just oak sustainability and some of the challenges that we face, first I would say that crop tree release is fundamentally a tree-focused treatment, and because of that, it doesn't necessarily consider the stand level oak sustainability challenges. But despite that, I think that it does have effects on it, and it can be leveraged to address some of those challenges. One way is that it promotes oak in the canopy by selecting and releasing oak crop trees. You're controlling the seed source for that stand, you're controlling the composition of canopy, and removing seed sources that you might not want in your stand. Again, it stimulates stand-wide growth, and I'll talk a little bit more about this applied to sustainability in the next slide. And it seems to either harm or help oak regeneration, which leads me to think that combined with an understory treatment, crop tree release could be a way to actually promote oak regeneration. And the reason that I think that, and kind of returning to that idea of stimulating stand-wide growth, is that if we look at this percent stocking chart again, and I've added the beginning, the pre-treatment percent stocking on the left, we can see that the stands are overstocked prior to crop tree release, and that it drops below that overstocked line to a little bit under 90%. And so that has basically a similar effect to a light thinning. And in some stands, I think that this would imitate basically reducing the canopy density and allowing better light levels into the forest floor. And if this was combined with an understory treatment that addressed some of the competition at the forest floor, that it could promote oak regeneration and recruitment. And finally, I just want to talk about some other possibilities that I see with crop tree release that make it desirable as a treatment. One is that it's scalable. Again, the economic research maybe needs to be teased out here. However, given that it can be applied kind of late in stand development as a commercial thinning, the possibilities for it to be scalable to a small forest land holding are good. Ward, in his paper in 2008, just observes that it's a fairly aesthetically pleasing treatment, and it might fit well into these multiple landowner objectives. And then last is it's accessible. You could talk about it as like gateway silviculture maybe. It's easy to understand. Landowners don't need to know about forestry concepts like basal area or thinning methods to understand the treatment. And it potentially can engage landowners in active management of their forest. And there have been studies that have shown that separation from nature undermines the stewardship of nature. And so really, I think accessible silvicultural treatments for landowners are important as we face these challenges in oak management. They're important in that they engage landowners with the problems with their woods, and create maybe that stewardship ethic in people. So with that, I would like to thank Dr. Laka, Dr. Stringer, and Dr. Achuto, my committee, for all of their help in this research, for their guidance. It's been very helpful. They've been above and beyond their duty. I'd also like to thank Zach, Joe, Wendy, and David for help in data collection, and the University of Kentucky Department of Forestry and Natural Resources, as well as the USDA McIntyre-Stennis Cooperative Forestry Research Program for funding. These are my references. And with that, I'll take any questions.